Now we'll go through the examples following all those theorems for 12-2. First example, we need to find the value of each variable to the nearest tenth. From what I see here with this 90 degree, that means that the chord LM is being bisected by this guy. So when it's bisected, that means LN, that little piece, is congruent to NM. And if I know that the whole thing, LM, the chord is 14, I know that each of these is 7 centimeters. So now I'm working in a right triangle where I have 2 out of the 3 sides. So I'm going to have to use the Pythagorean theorem. So for all these, we will probably have to use Pythag. So my hypotenuse is r, so it's going to be r squared is equal to 3 squared plus 7 squared. So r squared is equal to 9 plus 49. R squared is equal to 58. And r is the square root of 58. And we look at the directions to see what we're going to go towards. And we are trying to get to the nearest 10. So the decimal approximation for that is 7.6. My units are centimeters. So it's approximately 7.6 centimeters. So for all of these, we're going to be using the Pythagorean theorem because we're going to be working in circles where we're going to also have right triangles. So moving on to B. So I'm working backwards now. I have that AF, this chord is being bisected because these are congruent. So that means that BC is going to be perpendicular. So either it's perpendicular, so it bisects, or it bisects, so it's perpendicular. And then we'll also need, it looks like we're going to try and find Y, and 2 out of these 3 I think are filled in. We've got 11 here. And then we also need to know the hypotenuse of this triangle. And since AB goes from the center out, it's a radius. And we know the length of the radius. We have another radius here. So if this is 15, the other radius will also be 15. So we're in a right triangle and we've got 2 out of the 3 sides. So it goes y squared plus 11 squared equals 15 squared, because 15 is our hypotenuse. So it's y squared equals 225 minus 121. Y squared equals 104. Square root of 104, which is approximately 10.2, and my units, I don't have any, so they're 10.2. And we should just make sure that y, since it's not the hypotenuse, this guy, it's not the hypotenuse, so it should be less than the 15. That's how you kind of double check your answer. Third example, similar process. We know from this picture that if we have the 90, that means that this guy will bisect our chord. So if the whole chord is 12 units long, each part is going to be 6 units long. So now we're in a right triangle where we're missing 1 out of the 3 sides. We're going to use Pythagorean theorem again. So it's x squared, my hypotenuse, is equal to 6 squared plus 5 squared. And we'll get 36 and 25. X squared is 61, and we're looking for the square root of 61, and we're still looking for an approximate answer rounded to the nearest tenth. and we get 7.8 and no units, so we're just boxing that up. Last example like that, we look at this chord here. So I've got a chord, and it looks like we've got this line bisecting that chord, so both of these are 5, which means if that's true, I've got a 90 degree here. And now I also, since this is a radius, this is also a radius. It goes from the center out, so this is 9 units. And now I've got 2 out of my 3 sides, and I'm going to use Pythagorean theorem again. Hypotenuse is 9, so that means x squared plus 5 squared is going to be equal to 9 squared. The order in which you write these doesn't matter. If you wrote it as 9 squared is equal to x squared plus 5 squared, you will still be able to solve for x. I just like having my variable in the front. So we'll get 81 minus 25. And we get 56, and x is the square root of 56, which is approximately 7.5. So rounding to the nearest tenth. The last example looks a little different. It's not on your page, but it will be in the homework. You'll see an example where you have 2 circles where you have, and I'm going to try and draw this nicely, you've got segments at the center here of your circle. This is a center, that's a center. We've got points there. And it'll be labeled A. Segment AB will go from one center to the other, and segment CD, those will be chords for those. And you'll be given that AB is a value, so let's say AB is 30, CD is 16, and you'll need to find the radius of these congruent circles. So what you're going to need to note are these lengths that they gave us. AB is 30. So if I'm going all the way across, AB is 30. And then CD is 16. These are going to actually bisect each other here. So that'll mean that C to this point right here will be 8 units, and half of AB will be 15 units, and this will be perpendicular. And so the radius from the center to the outside, this guy is what we'll be looking for. And if you notice, it's kind of hard to see with all this writing, but we have a right triangle here where we have 2 out of our 3 sides. So we're going to be able to find it. Also, please learn your Pythagorean triples if you haven't, because it's 8 squared plus 15 squared equals r squared. If we don't know that this is a triple, we can do all the work. If we do know that it's triple, we know that the radius is 17. So we have a lot of things being bisected in this last example, right?